Next definition, pole. A pole of a function f of z, complex function f of z, is a point in the complex plane at which the value of the given function f of z becomes infinite. So if you put the value of z, that function, then the function becomes infinite. Then the point is called pole of that function. It is a isolated singularity, correct? So pole is an isolated singularity of that function. Example, take 1 by z. When z is equal to 0, this function f of z becomes infinite. So z is equal to 0 is a pole. Similarly, take sin z by z minus 2. When z is equal to 2, the function becomes infinite. So z is equal to 2 is a pole of that function. Order of the pole. Order of the pole is the power of the factor that is going to 0 in the denominator. For example, you take the function z square plus 1 by z minus 5 divided by z minus 1 power 4, z minus 8 power 2, z plus 3. When z is equal to 1, so denominator 1 minus 1 first factor, 0, right? So something into 0, 0, denominator 0. So the function f of z becomes infinite at z is equal to 1. So z is equal to 1 is a pole. Similarly, you can take z is equal to 8. So z is equal to 8, the function becomes infinite. So z is equal to 8 is a pole. When z is equal to minus 3, again the function becomes infinite because z plus 3 in the denominator. When you are putting minus 3 plus 3, 0. So totally denominator 0. So you will get infinite. So z is equal to minus 3 is a pole. Now order is, consider when z is equal to 1, what is the power of z minus 1? That is in the denominator, right? You have to take the denominator function only, right? Z minus 1 power 4. So z is equal to 1 is a pole of order 4. Similarly, z is equal to 8. What is the power? Z minus 8 power 2. So z is equal to 8 is a pole of order 2. Then minus 3. Z is equal to minus 3. What is the power of z plus 3? 1, right? So z is equal to minus 3 is a pole of order 1. Right? Now take cos z by z into z square plus 16. Z is equal to 0. It's a pole of order 1. Then z square plus 16 can be written as z plus 4i into z minus 4i. Right? So z is equal to 4i is a pole of order 1. Z is equal to minus 4i is a pole of order 1. Pole of order 1 is called simple pole. Right? A special name for that. Simple pole. A pole of order 1 is called a simple pole. Next sum, how to find pole. So to find the pole, just equate the denominator of the given function f of z to 0 and solve for z. So the f of z is some numerator function and denominator function, is a rational function. So to find the pole, you just equate, take the denominator function and equal to 0, factorized and equal to 0. So you will get value of z, right? You have to solve, right, the denominator function, right? Then you will get value of z. That value is nothing but pole of that given function. Some formulas to find the residues. Residue of f of z, z power n minus 1 at pole of order 1. So how to find the residue when the pole of order is 1? Residue of f of z, z power n minus 1 at z is equal to a, pole of order 1 is equal to limit z tends to a, z minus a, f of z, z into z power n minus 1. If the pole of order is 2, suppose z is equal to a is a pole of order 2, then residue of f of z into z power n minus 1 is equal to limit z tends to a d by dz of derivative of z minus a square f of z power n minus 1. If pole of order 3, z is equal to a is a pole of order 3, residue of f of z, z power n minus 1, which is equal to 1 by 2 factorial. Limit z tends to a d square by dz square, second derivative, right? Z minus a cube f of z, z power n minus 1. In general, z is equal to a is a pole of order m, then residue of f of z into z power n minus 1 is equal to 1 by m minus 1 factorial. Limit z tends to a d power m minus 1 and dz power m minus 1. M minus 1th derivative z minus a power m f of z, z power n minus 1. We'll see the problem. Find z inverse of z square minus 3z by z plus 2 into z minus 3. Let f of z is equal to z square minus 3z by z plus 2 into z minus 3. So multiply by z in z power n minus 1 on both sides. So z power n minus 1 into z square minus 3z by z plus 2 into z minus 5. So taking z common in the numerator, so you will get z power n minus 1 z into z minus 3 by z plus 2 into z minus 5. So f of z into z power n minus 1 is equal to z power n minus 1. You can separate z power n minus 1 into z power n into z power minus 1. So you already have one z in the numerator, that is z power 1. So grouping those two, z power minus 1 plus 1. So you will get z power 0 is equal to 1. So it will become z power n in the numerator into z minus 3 by z plus 2 into z minus 3. To find the pole of f of z into z power n minus 1. So we take the denominator function. So denominator, what is in denominator? Z plus 2 into z minus 3. So z minus 5, right? Take z plus 2 into z minus 5 equal to 0. So solve for z. So clearly z is equal to minus 2 and z is equal to 5. So z is equal to minus 2 is a pole, which is a simple pole because order is 1. And z is equal to 5 is a simple pole whose order is also 1, right? Now we find the residue. First residue R1. The residue of f of z is z power n minus 1 at z is equal to first point a. Formula, we know for formula, limit z tends to a, z minus a into f of z, z power n minus 1. So here a is equal to minus 2. Take the first pole, right? Minus 2. So you will get r of 1 is equal to limit z tends to minus 2, z plus 2, right? Put a is equal to minus 2, that's all. So f of z power n minus 1, we know z power n into z minus 3 by z plus 2 into z minus 5. So z plus 2 into z plus and denominator z plus 2 get cancelled, right? So which is equal to limit z tends to minus 2, z power n 2 minus 3 by 2 z minus 3 by z minus 5. Substituting the values of z. So when you are putting z is equal to minus 2, so minus 2 power n. So minus 2 minus 3 in the numerator, denominator minus 2 minus 5. So which is equal to minus 2 power n minus 5 by minus 7, that is 5 by 7 into minus 2 power n. This is first residue R1. Now we need to find the second residue R2 at a is equal to 5, right? So R2 is equal to same formula because pole is of order 1, simple pole, right? Residue of f of z is z power n minus 1, z is equal to a. Limit z tends to a, z minus a into f of z into z power n minus 1. When a is equal to 5, R2 is equal to limit z tends to 5, z minus 5, z power n into z minus 3 by z plus 2 into z minus 5. So z minus 5 and z minus 5 in the denominator get cancelled. So limit z tends to 5, z power n, z minus 3 by z plus 2. Substituting z is equal to 5, 5 power n, 5 minus 3 by 5 plus 2. That is 2 by 7 into 5 power n, right? That is R2. We know, right? method of residue, right? F of n, which is equal to sum of the residues into sum of the residues, right? R1 plus R2 is equal to 5 by 7 minus 2 power n plus 2 by 7 into 5 power n, right? Thanks.